Welcome back, friends. In today's lecture, we are going to give you an understanding of how to develop pedestrian level of service for the various links, intersections along a urban street. Okay. So, we are going to look at an urban street, look at what are the functional elements in the street, and then give you an idea about how to develop a pedestrian level of service for the intersection and the links. This is based on the Highway Capacity Manual 2010 version developed in the United States. Such methodology can also be now adopted for the Indian situation. However, if you understand what is involved in the current methodology, you will be in a better place to adopt it. So, this is just a basic overview of the Highway Capacity Manual, which was published by the Transportation Research Board of the US National Academy of Sciences. It has had several versions so far, but it has been very widely used in the field of vehicular transport. However, in the last couple of versions or editions, they have developed multimodal analysis. They have included pedestrian levels of service, both qualitative and quantitative. So, this is what we are going to look at when we are looking at this lecture and also some of the following lectures. So, when we are talking about pedestrian level of service, even in the Highway Capacity Manual, it is based on the Landis method, which we have already introduced to you. It says that the user's perception is influenced by both the roadway and the traffic characteristics. The roadway characteristics include the built walking environment, sidewalk design, infrastructure and the physical components, whereas the traffic characteristics include the flow of pedestrians and vehicular traffic on the road. So, overall, if you look at what form or what equation, if you think about it in that terms, how do you determine pedestrian level of service or score? It is a function of the built environment factors, right, plus some sort of additive function of another function of flow characteristics, and then you always have a constant or the unexplained part of the equation, right. So, at a gross level, it is a summation of the functions of function of built environment factors and the flow characteristic factors, and this is essentially what the diagram is also telling you. So, in this analysis, what is done is the entire analysis segment is divided up into separate units, right. There are formally 4 units of analysis, each of which receives a PLOS score, right. So, each of which receives a score, and then that score is converted into a scale of A, B, C, D, E to give you the pedestrian level of service. So, what are these 4 formal units? The first unit is the intersection, right. So, the intersection is a crossing of any street. So, if you look at this, will be the intersection. So, that is the first unit. The second is a link. So, a link is nothing but the distance, this one. So, link can span more than one block if the intersection is not signalized or where the vehicular traffic does not stop. So, here the link is the distance between these 2 streets. So, that indicates that there must be a signal at these 2 junctions, and that is why this is being considered as a link. If there was no signal at this junction, so the link would then be the entire distance between these 2. Okay. So, that is essentially the understanding of the link. So, just remember again, the link does not include the intersection if it is signalized. However, if it is not signalized, if it is N non-signalized, then it will also include the intersection as well. Okay. So, that is how a intersection and a link is described. The next unit of analysis is what is called the segment. Now, what is a segment? Segment combines a link scores and the downstream boundary of the intersection scores. Now, the segment is a combination of a link and an intersection. Okay. So, this entire thing is called a segment. So, when we are developing a pedestrian level of service score for a segment, it will include the pedestrian level of service score for the intersection as well as a pedestrian level of service score of the link. So, that is what essentially a segment means. And then the final unit of analysis is the facility in itself. So, the facility, when we talk about the facility, we talk about the entire stretch now. Okay. So, we are talking about the entire stretch, the length weighted averages of the segment scores. So, when we are developing a pedestrian level of service PLOS score for a facility. So, when we are developing this for a facility, what we are doing is we are doing a summation of a length weighted averages of the segment scores. Now, we know the segment scores, which consists of the scores of an intersection as well as a link. Now, the facility will have the length weighted averages of each of these segments. Okay. So, that essentially what a facility or how a PLOS score for a facility is developed. So, now let us start one by one with showing the all different 4 formats of units of analysis, and start with the smallest unit of analysis, which is the intersection. Before we do that, let us just tell you that the segment and facility scores are always on each side of the street, right. So, remember if there are facilities, walking facilities on both sides of the street, then the segment and facility scores are different for different sides. So, that means that there may be one road which has 2 pedestrian facilities up and downstream or up and down. However, it is not just enough to develop the level of service for only one side. So, if this is one footpath and this is the other footpath. So, then each of these will have the PLOS score has to be developed differently when you are looking at a segment PLOS score and the facility PLOS score. Okay. And the limit of period of time of study is limited to 1 hour. So, when we are developing when we are looking for the flow and speed and density of how people are walking, we limit it to 1 hour time periods, because it has been observed that the pedestrian flows vary greatly from hour to hour. So, we just keep it down to 1 hour. And then what usually happens, like we said, is you get a score for each, either the intersection or the link or the segment or the facility. You will get different scores, and those scores are then scaled into different grades, which gives you the pedestrian level of service. So, these are the pedestrian level of service scores, and which are converted into a pedestrian level of service grade. Okay. That is how you know how well your facility or your intersection is working. Remember, level of service or pedestrian level of service is a performance measure which allows you to gauge or understand how well your facility is performing as per the stated objectives or functions, right. If the function of the facility is to provide mobility to pedestrians, then how well is it providing mobility, or if the function is to provide safe crossing of pedestrians, how well is the pedestrian or the pedestrian crossing providing it. So, that is what any level of service, in this case pedestrian level of service, measures. So, if you look at if you start looking at the intersection, all of this may seem very daunting, these equations and further equations, but they are very simple, and we will look at it one by one. So, if you just look at each intersection, if you look at a snapshot of an intersection, so you would always have an intersection where a major street crosses a minor street, right. So, if this is a major street and if this is the minor street and they are all intersecting, both of them have sidewalks, right. So, you know what is the width of the crosswalk, how much you have, what is the width of the sidewalk, all of these are measurable. So, what this highway capacity manual tells you that the intersection pedestrian level of service score is given by a formula or a model or a linear regression equation, which is a function of these 4 different elements. Now, what we will look at, these 4 different elements are again further given by certain standard formulas, and these all formulas, the input to these formulas have to be collected on the street. So, for the particular intersection for which you want to develop a pedestrian level of service, you have to always capture certain amount of data. That data, if you put it in this equation or in this model, it will give you a pedestrian level of service score for that particular intersection. Okay. Now, let us look into what individually all of these 4 elements are. So, the first element, which is FW, is the factor of the a factor which denotes the road crossing width. Okay. So, the width of the road that you will be crossing. Okay. There may be crosswalks on both sides, right. If you are here, you may be wanting to cross either this street or this street. So, the width of the the road you are crossing, right. So, if you are crossing this road, what is the width? If you are crossing this road, what is the width? So, that is a factor. So, if the width is small, your pedestrian level of service score will be different, whereas if the width is large, your pedestrian level of score may be different. So, that is a factor that controls the pedestrian level of service score. The next one is the volume of the vehicles on the street on which the crosswalk is located. So, this is a factor that governs the volume of the streets. Now, if you are trying to cross this way, what is the volume? If you are trying to cross this way, what is the volume of the traffic on this road? Versus if you are trying to cross this way, what is the volume of the traffic on this road, right. So, that governs what the level of or pedestrian level of service score of the intersection is. The third one is the speed of the vehicles on the street on which the crosswalk is located. So, you have to not only calculate the width of that road, the volume of vehicles on that road, but you also have to know a speed of vehicles on that road. And finally, the fourth one is if there is a pedestrian signal, right, if in case there is a pedestrian signal. So, what is the delay to the pedestrians due to these signals? I mean, if not only pedestrian signals, if it is a signalized intersections. So, if the pedestrians have to wait there due to the presence of a signal, then what is the delay that the pedestrians face? Again, this delay is due to signal at the intersection, not only a pedestrian signal, but a regular vehicular signal as well. So, what is the delay that is incurred or faced by the pedestrians at that intersection? Okay, clear? So, the pedestrian level of score depends upon 4 factors. The first factor is the width of the sidewalk or width of the crosswalk or the width of the road which you are trying to cross, right. So, width of the road that you are trying to cross, this width, first factor. Second factor, the volume of vehicles that are on that road that you are trying to cross. Third factor, the speed of the vehicles along that road that you are trying to cross. And finally, the last factor is if it is a signalized intersection, if there is a signal at that intersection, then the delay faced by the pedestrians because of the signal, okay, because of the signal. So, those are the 4 factors that determine the pedestrian level of service score at a signalized intersection. Now, furthermore, if you break it down for each of these factors, you will see that the width factor only depends upon the number of lanes crossed at the crosswalk. It is a function of, so it is 0.681 times ND to the power 0.514. So, it is an empirical equation, empirical format, where it is only dependent upon empirical formula, where it is only dependent upon the number of lanes you have crossed. So, if you know the number of lanes, you just plug in the number of lanes here and you get the factor of FW. Whereas, if you want to know the volume, of the vehicles that are crossing that are on that road, what you have to do is you have to measure 2 terms. Okay? The sum of the turning volumes left or from right coincident with the walk phase per 15 minutes. Coincident with the walk phase. So, when sometimes you always have signals where the vehicles are also moving and you also have a green for pedestrians, right. So, that volume of vehicles. So, for example, if I draw an intersection if I draw an intersection, let me draw another one. If I draw this intersection and you are waiting here and you are wanting to cross this road. Okay. So, what happens is you have left turning vehicles, you are wanting to cross here, you have left turning vehicles and also you will have some right turning vehicles which are coming here. So, the volume of these right turning vehicles plus the volume of these left turning vehicles will affect how you will cross, right. So, that is essentially the volume that you have to calculate in order to determine. So, if you know the volume, you just add it, divide it by 4, multiply it by that factor and you will get the first element in FW. The other elements in FW are N, which is the number of right turn channelized islands on the crosswalk. Now, if there are any channelized islands, you just have to count the number of channelized islands. It is as simple as 1 or 2, most likely there are never more than 1 or 2 channelized islands, and the smaller n gives you the volume of the vehicles per lane per 15 minutes. So, if you know the volume of the vehicles per lane per 15 minutes, you just multiply that factor by that, multiply that by this factor and multiply it with the number of channelized lanes. This entire thing will now give you the FV volume or the factor which determines the volume of vehicles that are on the road that you are trying to cross. Okay. So, now you know FW, you know FV. Finally, you also have to calculate Fs, right. You want to know the speed, you want to know the speed of the vehicles on the road that you are trying to cross. So, when you want to know the speed of the vehicles, you have to know the volume which you have already calculated, right. You have calculated the volume for the 15-minute period. Along with that, you have to calculate what is called the 85th percentile speed. So, in order to just calculate the 85th percentile speed, it is nothing but the speed that 85% of the drivers will drive at or below under free flowing conditions. You just develop a cumulative frequency curve of the volume of the vehicle count and the speed, right. So, if you just do a cumulative frequency and at the 85th percentile, if you draw the at the 85th percentile, if you draw the speed, if you extend the 85th percentile speed and look at the x axis, you will know what is the speed of the vehicles at which 85% of the vehicles are moving, right. That is the speed we want to know. Usually, we don't calculate the mean speed, because it has been found out that 85th percentile speed is a safe speed to assume that many people that many number of vehicles are moving at that speed. So, we want to determine the 85th percentile speed. So, once you know the 85th percentile speed of the vehicular stream, you just multiply that with the volume and the factor, you will have the factor Fs. Now, you know Fw, Fv, Fs. The final thing to know is F delay, which if there is a signalized intersection, pedestrian delay at signals. If there is a signalized intersection, we already know how to calculate the delay at signalized intersections, right. This is the cycle length minus the effective green time squared by twice the cycle length. We have already explained it to you previously. In addition to that, if you want to calculate the count of the vehicles crossing the crosswalk and the volume and that is the volume of the vehicles per lane per minute, that is crossing the crosswalk. Okay. So, that is crossing the crosswalk. If you calculate that, you already know the number of lanes. So, you can then determine the delay, which is given by this formula. Okay. Here you will determine the count, here you will determine the delay, and if you use this formula, you will get what is called the F delay factor. So, now you know all of the 4 factors, you just plug it in this formula, add it to this constant, and you will know the intersection pedestrian level of service score. We will give you an example of a problem. So, you can then relate it back to the formula, relate it back to this individual formulas, and that will make you understand it much better. Before we do that, let us also give you an example of how to determine the pedestrian level of service score for the link. Remember again, link is between two signalized intersections, right. If it is two signalized intersections, the distance between that is called a link. If there is no signalized intersection, then you start from one signalized intersection and go till you reach a signalized intersection. That entire length is called the link. So, the pedestrian level of service score of the link depends upon two things, that is the pedestrian level of service score for the intersection, which we have already looked at, and now then it is also dependent on the flow characteristic modeling of the average space. Now, this also depends upon the average space. Now, the minute you are talking about link, because in the link number of people would be walking. So, the average space available for the people to walk, that also determines the pedestrian level of service score for the link. So, two elements in this, a pedestrian level of service score similar to the intersection calculation, right, that we looked at, and the other one is the pedestrian level of service for the average space. So, based on those two, the worst of that will give you the pedestrian level of service link for pedestrian level of service score for the link. Similarly, just as for the intersection, you had 4 factors to determine the pedestrian level of service. Here you have only 3 factors. The constant, you have a constant term as well, which is different in this case. But again, let us quickly look at how do you calculate these 3 factors. You already know these about them, right. This is the width, this is the vehicle, volume of vehicles, and this is the speed of vehicles along that. So, these 3 components are included, and then for the score, you know that for the average space, you know that we always have to calculate the effective width. This effective width is reduced if you consider parking, right. You already know how to calculate effective width. So, if you start looking at each of these factors, again FW is the, this time is the sidewalk width. Remember last time when we were calculating the intersection pedestrian level of service score, that FW was the crosswalk or the width of the road that you are trying to cross. In this case, it is the width of the sidewalk, because you are talking about a link. FV remains the volume of the vehicles and Fs remains the speed of the vehicle. So, what this tells you is that the link on which you are walking, or example the footpath on which you are walking, the pedestrian level of service, even though you are walking on a segregated pedestrian facility, it depends upon the volume of vehicles that is running on the adjacent street, right, and also the speed of the vehicles. So, you should not always segregate, should not always think that putting a sidewalk on a high speed road will entice more people to walk on it, because it will not, because the pedestrian level of service score usually goes up. PLOS score going up usually meaning that the level of service is going down. So, if you have high speed vehicles alongside a footpath, usually the score will be high, because you know these are all additive functions, and the score being high usually means that the PLOS is low. Okay. That is how score and PLOS are related to each other. So, if you have to calculate, again if you look one by one, if you have to calculate the factor that that influences the sidewalk width, you have to know first, this is again given by this quadratic or this simple linear equation. You have to know the effective width of the outside through lane, bike lane, and the shoulder. So, we will tell you in a diagram in the coming slides how what do we mean by the outside through lane, bike lane, and shoulder, but it should be, we are calculating the effective width based on the outside traffic lane, okay, not the ones inside. Inside meaning the traffic lanes that is closer to the median, outside meaning the traffic lane that is closer to the footpath. Okay. So, that width, then you have to have the effective width of the combined bicycle lane and shoulder, bicycle lane and shoulder. So, this is the effective combined width of the bicycle lane and shoulder, whereas this is the effective width of the outside through lane, bicycle lane and shoulder. Finally, or not finally, but there are other 2 items, which is the buffer, the width of the buffer that is available, if there are any plantations or anything that is on the between the vehicles and the pedestrians, and the other one is the effective width, which we will know, which will tell you what it is. Okay. Then finally, for the other two factors, for the vehicle volume factor and the vehicle speed factor, for the volume factor again Vm, you have to determine the mid block flow rate. Okay. You know already how to calculate flow rates. So, you have to determine the mid block flow rate. So, at the middle of the link, okay, at the middle of the link you have to determine the flow rate, and for speed again we will tell you whether it is the 85th percentile speed or which speed you have to calculate, but they are again given by these three formulas. So, here it is, if while calculating Fw, when we say Wv or the outside lane, this is what we are meaning. If the sidewalk is here and then you have a buffer, some kind of plantation, and then you have your curb and gutter here. So, then the first one may be just a shoulder or the parking lane, then you may have a bicycle lane, and then maybe your outside travel lane is starting. So, you have to this entire distance is called your Wv. If you want to only know the WL, effective width of the bicycle lane and the shoulder, that is your WL. Okay. The PPK factor is the parking, the proportion of the distance that is covered by parking, proportion, just the proportion of the lane that is covered by parking. All right. Now, there are some certain conditions that you have to take into account while you are developing these width factors, and these are standard conditions that have been again developed based on certain urban conditions in the United States. Because we do not have specifics for our country or for our Asian environment, we will still go with these, but this is for your understanding. Maybe when you are conducting field experiments in the in your city or in any different parts of India, these factors may change, but you have to at least have an understanding of how do you determine this. If for example, there is no parking versus if the parking at least 25% of it is covered by parking, no more than 25% of it is covered by parking, then how do you determine those effective widths? They are given by this condition, they are given in this table, and it is just plug and play. You just have to pick which condition you are dealing with, and you just have to determine simple widths. For Fs, again in this case we are just determining the vehicle running speed, we are not determining the 85th percentile speed. So, it is very you just have to calculate the vehicular running speed, you may conduct certain spot speed studies in order to understand what the vehicular speed is, running speed is. For volume, all you have to know is the number of through lanes on the street in the direction of the travel being considered. If you know the number of through lanes, you are already calculating the volume of vehicles per 15 minutes per lane. If you plug in those, you will get the factor of volume. Now, that the other two things that were included in the FW term, one was, remember, the adjusted available sidewalk width. So, you have to, there is a factor that you have to multiply the buffer width. Okay. WB was the buffer width. If there was a plantation or tree plantation, that width is called the buffer width between the roadway and the sidewalk. With that buffer width, you have to multiply that with a factor which tells you the available sidewalk width. That factor multiplied gives you this element. Similarly, for the last element, I am sorry, that this factor is the presence of the continuous barrier for at least 3 feet high. All right. So, let us make it again clear. You first have to, for this term, you have to understand what is the width between the between the roadway and the sidewalk, that is the buffer width. Once you know the buffer width, if you feel or if you see the presence of that buffer for a continuously, and that buffer is at least 3 feet high, then this factor, this FB factor is 5.37. If it is not, then the FB factor is 1. So, that is a very empirical. So, you can understand it is a very empirical way of doing things. These were done in 2 or 3 locations in the United States, and based on those site specific locations, this formula was developed. Okay. So, if the buffer exists and it exists continuously, and the buffer and the width of the height of the buffer is at least 3 feet, then this factor is 5.37, otherwise the factor is only considered as 1. Finally, the last term is the adjusted available sidewalk width. Adjusted, we will let you know what is the adjusted versus what is the available sidewalk width. Along with the adjusted, you have a sidewalk width coefficient that you have to multiply this with, which is given by the simple formula of this. So, once you calculate FW, once you calculate FV and once you calculate FS, you just plug it in this formula, add it to the constant, you will get the PLOS of the link. Okay. Remember, we are talking about the PLOS score of the link. Now, again going back, you remember that for the link you have to have two different PLOS calculations. One is that we have just calculated, the other one is based on the pedestrian space. You already know how to calculate the pedestrian space. For the number of pedestrians per hour divided by the effective sidewalk width will give you the pedestrian flow per foot per sidewalk width. Average walking speed, more pedestrians are there, more crowded. So, you know the average pedestrian speed, you know the average pedestrian flow rate, divide the average pedestrian speed by the pedestrian flow rate, which gives you the pedestrian space. Okay. Pedestrian space is given by square foot per pedestrian. How much space individual pedestrians need? Square foot per pedestrian, dividing the average walking speed by the pedestrian flow. Remember, the basic equation is flow is equal to speed into speed by, it is either speed into density or it is, since density and space is different, it is speed by space, right. So, that is the basic relationship. So, based on that relationship, you are calculating the pedestrian space. Now, if you know the pedestrian space and if you know your pedestrian level of service score that you have calculated for the links, you can then for each given pedestrian space, you will have a corresponding pedestrian level of service score, right. So, you see that it is very difficult to achieve a pedestrian level of service score, pedestrian level of service of A, because that is only available in this condition, when the score is less than 2 and when the space is greater than 60. Otherwise, in any of these you do not have a level of service A. So, usually we do not design for a level of service A. That brings us to the end of this lecture. However, we will continue this lecture in the next half an hour. We will continue this same series, because we have only looked at the intersection and the link. Next, we will look at the segment and the facility, and we will give you some examples of this, so that you are thorough with the understanding. These are the references. So, in this lecture, we have looked at the Highway Capacity Manual 2010 version of how to develop a pedestrian level of service score for a intersection as well as for a link. Okay. Intersection as well as for a link. Thank you for your attention.